Hello, I'm Varun Joyce.
I'm Shubham Quadro.
I'm Varun Yu.
I'm Vivek Shane.
I'm Suhas Motwani.
We are from BMS College of Engineering, EC Department, 6M. We have built the child safety system for TIIC IDC 2015. Hello, I'm Varun M. Joyce. We have built a child safety system for the TIIC IDC 2015. Our primary design objectives are: one, we would like to monitor the proximity of the child to a safe point, and second, we non-invasively monitor the distress signals of the child, and if it exceeds a certain threshold, the parents must be notified of the child's location via GPS. With this, we hope to reduce the amount of crimes on small children.
Hello, I'm Varun and I'll walk you through the connections and the circuitry of our project. This is the heart of our project, which is the MSP 430 launchpad. This is the state-of-the-art equipment given by Texas Instruments, which consumes very low power and which is easily programmable. Coming to the sensors, we have two biosensors and one Bluetooth module. The first biosensor is our heart rate sensor. This is basically an IR sensor and we have converted into an heart rate sensor. The circuitry of the heart rate sensor consists of a low pass filter and then an operational amplifier. The heart rate sensor gives an initiation whenever the heart rate of the child increases to a certain threshold. The second biosensor is our galvanic skin sensor. This continuously keeps monitoring the skin resistance of the child and gives an initiation whenever the skin resistance crosses a certain threshold. The next sensor is our Bluetooth module. This is the Bluetooth module which will be with the child, and it is connected to another Bluetooth module which will be either the mobile of the parent or which will be a host at the school or whatever or wherever it is needed. So whenever the distance between the two modules is increased and whenever the connection is lost between them, it gives an initiation. So the next thing is the GPS module and its antenna. This continuously keeps monitoring the position of the child and gives the position whenever the initiation is done. Then we have the GSM module, which basically sends a message whenever an initiation is given. Then we have the multiplexer. We have used the multiplexer because we wanted the GPS module and the Bluetooth module to work with the same serial port, that is P1.1 and P1.2 of the MSP 430 launcher. Hence, we used a multiplexer to connect both of them together. Now we'll move on to the demo of the working of the project.
Hello, I'm Shubham.
And I'm Vivek.
And we are going to demonstrate the working of our project.
So whenever the device is turned on, the MSP 430, the GPS module, the GSM module and the Bluetooth modules are powered on.
Now the sensors are the galvanic skin sensor and the heart rate monitor. These two electrodes will be connected to the skin of the child and they will continuously measure the resistance of the child. The heart rate monitor will monitor the heartbeat of the child.
So when the heart rate or the skin resistance crosses a threshold, or when the Bluetooth connection between the module and the parent's phone gets disconnected, the track value of the GPS is sent to MSP 430, which then decodes the tracked value and sends a string to GSM module, which then sends a message to the parent's phone explaining the latitude and the longitude of the position of the child.
The working of the heart rate sensor and the galvanic skin sensor has already been tested and it is put in the report. Now here I will be demonstrating the working of the Bluetooth module. When the connection between the two Bluetooth modules is lost, the MSP 430 will send a message to the parent's phone. Now as you all can see here, the Bluetooth module is already connected to my phone. It is already paired with my phone. This HC05 is the Bluetooth module. Now as I move away from this device, I'll get a message on my phone saying the latitude and the longitude of the child's location. So now I've come around 10 meters or 15 meters from the device and I should be getting the message at any time. Now I got the message. As you all can see, the latitude and the longitude of the device is displayed as an SMS to me.
Hello, I'm Suhas Motwani and I will be listing out the results that we obtained by testing the device. Firstly, the performance of the MSP430 for computing needs was sufficient. Also, the power requirements of the GPS and the GSM modules we used were high. However, we are confident that with professional embedded design, this can be reduced. Another finding was that the sensor readings from the heartbeat monitor was a little unreliable as it uses infrared detection and thus susceptible to fluctuations of the environment conditions. Another point that we would like to note that the values of the skin resistance sensor were surprisingly accurate. Also, we isolated the GPS fixed data, that is the GPGGA sentence, to find the location in longitude and latitude form. The format is in degree.decimal, which can be directly entered into Google Maps to find the address. Lastly, we would like to state that although this is a large setup, after fabrication, we would like to make it into a smaller, wearable mobile unit. Thank you.